Okay. In the last video that I just finished, we were talking about linear versus exponential growth, and I just had to cut it kind of quickly at the end because I was running out of time on the length of the video that I can upload to YouTube. But I wanted to do one or two more examples of this lab that you're going to do on the differences between linear and exponential growth. Let's see. Suppose I'm given the numbers 2, 4, 8, 16, 32, list the growth factor. That's actually the one we just did right here. It's clearly 2. I multiply by 2. 2 times 2 is 4, times 2 is 8, and so on. That's pretty straightforward. But suppose I have this. $100, 75, 56.25, 42.19, 31.64. And as you start working with these, this is actually example 3 on your lab, on page 2 of your lab. Once you start working with these exponentials, you can end up with lots of decimals and all that. But we said before, we know the trick. If I can't look at this and immediately tell what I multiply by, frankly, what do I multiply 100 by to get 75? That might be a little bit confusing. But we said go backwards. Take the second number and divide it by the first. So do 75 divided by 100, and I get 0.75. To check that, do this divided by that. 56.25 divided by 75. Oh, I hit the wrong button. 56.25 divided by 75 equals 0.75. And I could keep on going, but clearly now I know my growth factor. It's 0.75. You're not told to do it in this problem, but if I wanted to write an exponential equation, y equals a times b to the x, a is my starting value, 100, times b, which is 0.75, to the x. And the point being, for all the other growth rates we've done, they were all like multiplying by 2 or 4. You can multiply by decimals, and they can be less than 1. They can even be negative in here sometimes. So be aware, things like that can pop up. Let's see. On page 3, there's actually problems here. Yes, they're good. Example 4. Grace's weight is 136 pounds, then 139, then 142, then 145. And the point here is, her weight is going up by 3 pounds per week. That is constant change, not constant percentage change, which means that would be linear. And then I'd have to write an equation. Y equals mx plus b. M is the slope. Her weight's going up by 3 pounds per week, so that's 3x, plus b. B is her starting value when x is 0. And if you think about it, in week 1, her weight is 136. So in week 0, her weight would be 3 pounds less 133. Because then when x equals 1, I get 133 plus 3, which is 136. And again, the idea here is ultimately, you know what linear growth is now. You're starting to learn what exponential growth is. And then you want to be able to combine those on any given problem and say, okay, here's a bunch of numbers. Here's a table of data. Is this linear growth or is this exponential growth? Okay, now that I know it's exponential, I need an equation, find my a and find my b. Oh, no, this one's linear. I have an equation, find my m, find my b. And then from there you can answer questions. If x is 4, what do you get? Plug it in, hit enter on your calculator. If x is 10, what do you get? Plug it in, hit enter on your calculator. And that's the goal here, like I said in the last video, to understand the 2 different types of growth and then to be able to solve problems with both of them and to understand them from a real world perspective. So this week, like I said, you'll have 2 labs. This one that we went over in the last video in detail, where you'll get to practice creating equations and using points on graphs and tables and things like that to generate exponential equations. And then this one, comparing exponential and linear growth and being able to generate equations and then potentially solve problems. Like I said in the last video, if you want me to do any more of these, like with more examples or whatever, just let me know. I just obviously am trying to limit the length of these videos so that you don't have to sit there for 3 hours every single week watching them. But I have no problem adding to them if this isn't enough. Just let me know.